All right, guys, we are going to go over the multiple choice part of the August 2024 Algebra 1 Regents. The Algebra 1 Regents did change slightly as of June of 2024. So I do want to go over those changes with you. The questions themselves, there was not much of a change as far as the standards go, but the reference sheet actually looks very different. So I do want to show you that at a glance before I go over the questions. This is the old reference sheet. Everywhere I have an X, those formulas are no longer on the new reference sheet. Those are all gone. So as you can see, the only surviving pieces are right here, the quadratic formula and then the sequences. Now, the fact that all of these area, circumference, volume formulas are all gone shouldn't scare you. You shouldn't think that you now need to memorize these formulas. What it actually indicates is that there is a very small chance that any types of problems that involve those formulas are even going to be on this test anymore. So don't be worried about that. The new reference sheet actually looks much, much better. So here is your new reference sheet. Everywhere where I have a little new sticker is something that was not on the reference sheet before, and it's going to be very useful to you. So the quadratic formula was there before, it's there now. Again, so were your sequences. But some new things that are going to help you out are not only do they have the quadratic formula, but they've also now put what the quadratic equation looks like. And this can be very helpful if you have a problem where you need to use the quadratic formula, but you're not sure what all of these variables in it mean. So if you're given an equation, let's say 2x squared plus 4x minus 7, and you're asked to solve it using the quadratic formula. So you know the formula, but you're confused about what B, A, and C are. Well, just look above it and you'll see that A is the coefficient of x squared. So in the example that I've wrote in red, my A value is 2. The B value is before x according to the reference sheet. And so in the example I gave you, it's 4 and so on. So that's how that piece of the reference sheet can help you. You're also given the equation of the axis of symmetry. So that is the line that splits. So if you have a parabola, the axis of symmetry is the vertical line that's going to split it symmetrically in half. So you have that. You have slope, which I think is crazy because 8th graders in New York have the slope formula memorized. But if you don't, well, they just made it a lot easier for you to pass this Regents. I think these are crazy as well, but good for you guys. They gave you the linear equation both in slope-intercept form and in point-slope form. So I know a lot of times reference sheets are looked over. There's a lot of formulas on there you don't need. That is not the case with this Regents sheet. I'm telling you, these are very useful. So know that these are there and come back to these, all right? You also have on the right, I just want to point out one more, the interquartile range. So that has to do with when you're drawing box plots or reading box plots. It's a very simple formula. It's just Q3 minus Q1. But of course, you need to know what Q3 and Q1 are in order to apply this formula. So there are things that you need to learn here, but the formulas are not one of them. They're here for you so you don't have to memorize them, all right? So reference sheet looks very different. Same thing about the conversions. You see there's way less conversions. I didn't even bother showing them. That doesn't mean that they now expect you to know how many yards are in a mile. They just, it's going to be way less problems that deal with those types of conversions. So don't worry about that. There are fewer there. That doesn't mean that you need to memorize more. So let's get right into it, starting with the multiple choice. So number 1 asks for the correct factorization of this quadratic. You can factor a bunch of this different ways. You can do GCF, difference of squares. When we see a quadratic that's in this format where it's x squared, x, and then a constant term, it's ax squared plus bx plus c. The way that we're going to factor this is with the product and sum method, or maybe your teacher called it the AC method. So when I think about the AC method, this is ax squared plus bx plus c. My product, when I say product and sum, the product is c. The sum, and I'll explain what this means in a second, is b. What I'm going to teach you only works when the coefficient of x squared is 1, but on the Algebra 1 Regents, it's always going to only be 1 in this case when they're asking you to factor this way. So the product is c. My c value here is negative 12. My sum is b. The b value is 4. What this means is that we're looking for two numbers whose product is negative 12. So two numbers that are going to multiply to negative 12, and those same two numbers have to have a sum of 4. So two numbers that multiply to negative 12 but add to positive 4 are going to be positive 6 and negative 2. Once you find what those two numbers are, to factor this, you just open up your two binomials. They're both going to start with an x, and we're going to put our numbers right in there. So we said it was a positive 6, so plus 6, and a negative 2, so minus 2. And even though it's not in the same order, you'll see that answer choice number 4 is the same as what I got. Multiplication is commutative. I can switch the order that I do it in, so those are the same thing. All right, so that is number 1. The other thing before I move on to number 2 that you could do for number 1 is you could just graph it in your graphing calculator. You could put x squared plus 4x minus 12 into y equals, and then actually I think I did that for you. Hold on one second. If you graph it, yep, so I have, no, of course not, clear it out. All right, well, I won't make you sit through all that. So if you graph the first equation and then you graph the factored version of it and they overlap, that means that they were the same equation to begin with. They were just written differently. So that's how I would check this, okay? Number 2, which situation can be modeled by a linear function? The most important thing to know about a linear function is that it has a constant rate of change. So it is either increasing or decreasing by the same amount for each interval. So choice number 1 says a printer can print 1 page every 3 seconds. That's it right there. That is a constant rate. So every second, it's printing 1/3 of a page, right? Every 1 page gets printed 3 seconds. So that is a constant rate. That is a linear function. I'll quickly talk about why the others are not linear, because at first glance, they might seem like they also have a constant rate of change. Number 2 says a bank account earns 0.5% interest each year compounded annually. So you might be saying, well, 0.5 each year, it's the same each year. Well, the same percent interest is not the same amount of interest each year because we're compounding annually. So if you got 0.5% interest on $1,000, that would be $5. But the next year, it's 0.5%, not of 1,000, but of 1,005 because we're compounding annually. So 0.5% of a different number is going to give me a different number. So it's not going to be constant, all right? Something similar happens with number 3. It says the number of cells in an organism doubles every 4 days. So if we think about this, let's do days and cells. So let's think about what happens on day 1. Let's say day 1, there are 10 cells in this organism. Every 4 days, so meaning that on the 5th day, it will have doubled. So if it was 10, now there's going to be 20 cells. Let's do another 4 days. So on the 9th day, that 20 is going to double and it's going to become 40. Well, now if we look for the rate of change, remember that's the same thing as slope. The rate of change between these first 2 ordered pairs is it's going up by 10 and then the days are going up by 4. So the rate of change would be 10 cells per every 4 days. So it looks like 2.5 cells a day. But then if I look at the next 2 order pairs, it's going to be 20 cells over 4 days. So that's a rate of change of 5 cells per day. So these two are not equal. It is not increasing by the same amount. So the rest of these answer choices are going to be exponential, not linear. So if you see that there's a percent involved, that's your hint that it's not going to be linear. All right, number 3, and this one shows up every year and it is pretty easy. Which expression is equivalent to the following? So there's a lot of simplifying to be done here. When I see a number outside of a parentheses, that means that I am distributing it. So I'm multiplying it to every term that's inside those parentheses. So I'm going to multiply this 3 out to all 3 terms that are inside. That's going to give me 3x squared minus 6x plus 9. Okay, now I have to distribute something else. Before this next parentheses, there is a minus sign. Think about that as being an invisible -1 right here. So that is also going to get distributed to all 3 terms inside that second parentheses. So -1 times 4x squared is -4x squared. -1 times positive 3x is -3x. And -1 times -1 is +1. You distributed the 3 out. You distributed the -1 out. Now we're looking for like terms to see what we can combine. All right, 3x squared minus 4x squared. When you combine like terms, remember that you're always taking the sign in front of the number as your hint of whether you're, not your hint, but it's telling you whether you're adding or subtracting. So this is going to be 3 minus 4. That's going to give us a -1. So that means I don't really have to write it. I could just write a negative sign. X squared. So when we combine like terms, we combine their coefficients and we keep the variable and the exponent the same as it was. The next thing I see I can combine is -x minus 3x. Again, looking at those signs in front of them. So negative 6x. Negative 6 minus 3 is negative 9. Again, keeping my x. And the last thing I can combine is these constants, these numbers, 9 plus 1, which gives me a positive 10. And when we look at the answer choices, we see that answer choice number 4 is our correct answer. Moving on to number 4. At Adeline's first birthday party, each guest brought $1 in coins for her piggy bank. Guests brought nickels, dimes, and quarters for a total of $28. There were twice as many dimes as nickels and 12 more quarters than nickels. Which equation could be used to determine the number of nickels X that her guests brought to the party? So let's take this information aside and start labeling things. The number of nickels, the problem already told us how we're going to represent that. They said the number of nickels is called X. So now we're going to use X and what we know about the other coins to write expressions that represent the number of the other coins. So if we wanted to write an expression that would represent the number of dimes, well, what we know about the dimes is that there are twice as many dimes as nickels. So when we talk about twice something, that means that we're multiplying it by 2. So if there are X nickels, then there are 2X dimes. And lastly, let's find an expression to represent the number of quarters. So the quarters, it says that there are 12 more quarters than nickels. So 12 more means that I'm adding 12 to however many nickels there were. There are X nickels, so that means that X plus 12 would tell me how many quarters I have. All right, now, the problem is talking about how much money we have. These expressions here are just talking about how many coins we have. That's different. The number of coins is not the same as the value of the coins. So we have to now write expressions that show the value of these coins. So I know sometimes teachers take it for granted that you guys know this because everyone's so used to Apple Pay and credit cards right now, but nickels are worth 5 cents each. So we're going to write that out as 0.05. Dimes are worth 10 cents, so 0.1, and quarters are worth 25 cents, so 0.25. So I shouldn't have written that one like that. So we're going to multiply the value of each of the coins by the number of coins. So 0.25, that's the value. I'm sorry, I just wrote that incorrectly. Let's erase that. 0.25, not 0.025. So 0.25 is the value of 1 quarter, and there are X plus 12 quarters. So this expression right here represents the value of all the quarters. Each one is 25 cents, but I have X plus 12 of them. So their whole worth is that part that's highlighted right now. Each dime is worth 10 cents, but I have 2X dimes. So I'm going to multiply 10 cents by 2X. And that expression is going to give me the value of all of my dimes. And then lastly, my nickels, I have each nickel being worth 0.05, and there are X nickels. So 0.05x is the value of my nickels. So now I have the value of my nickels plus the value of my quarters plus the value of my dimes, and all together that equals $28. So we're looking for the answer choice that says the same thing as what I have, and that looks like it's a different order, but that's okay. Answer choice number 2. Number 5 is all about vocabulary. This is one of these questions, you don't have to do any math. You just need to know what these words mean. So if you don't know them, I suggest making a flashcard, writing them in your notebook, however you're organizing your new knowledge, write these things down. A student creates a 4th degree trinomial. The degree of a polynomial is just the highest power of the x. So we see that we have x to the 4th, x to the 2nd, some just x's. We're looking for the highest power of the x. So if a trinomial is in the 4th degree, that means that x to the 4th will be the highest power that is here. So just looking at these answer choices now, I already see that I could eliminate 3 and 4 because 3 is in the 2nd degree. The highest exponent I see is a 2, and 4 is in the 3rd degree. The highest exponent I see is a 3. So those choices are already out. Now we keep reading. It says it's a trinomial. So a trinomial has 3 terms, but both of these answer choices 1 and 2 have 3 terms. So that doesn't help us eliminate anything, but it's still important to know that vocabulary. And then there's more vocabulary. It says it has a leading coefficient. So a coefficient is the number that's before the variable being multiplied by it. Like 4x, 4 is the coefficient. But when we talk about a leading coefficient, that means the coefficient of the term that has the highest power. So if we wrote it in standard form, it would be the first coefficient, because when we write polynomials in standard form, they go in order from highest exponent to lowest exponent. So looking at the x to the fourth term, we want the leading coefficient to be a 2. In both of these, it's a 2, so that doesn't help us either. So we go on to the last piece, which is that it has a constant value of 5. That word constant indicates that something is not changing, right? Variables change. A constant is something that does not have a variable attached to it. It just is that number. So we're looking for a constant value of 5, not 5 being multiplied by any variable. And you see that that happens here in answer choice number 1. So that is the correct answer choice here. When solving the equation 4x squared minus 16 equals 0, Laura wrote 4x squared equals 16 as her first step. Which property justifies it? Not much math here either. This is also honestly just some vocab. To get this equal to 4x squared equals 16, the step that they're not showing you is that she must have added 16 to both sides, right? 0 plus 16 is the only way that I would get that 16. And then if I add negative 16 plus 16, they'll cancel out. That's why there is no 16 on that left side anymore. So what they're asking us basically is, what is this called? What is it called when she added 16 to both sides? So let's go through these answer choices. Number 1, distributive property. Nope, that's when you multiply the number. That's outside of the parentheses, so that's out. Multiplication property of equality. That means that you multiplied an equation by the same number on both sides. We didn't multiply anything. Commutative property of addition. Commutative property means that you moved things around. You changed the order. So 5 plus x is the same as x plus 5. We didn't move anything around. We did do the addition property of equality, which just says that we added the same number to both sides of the equation. We did that right here in this highlighted step. Number 7 is more vocabulary. Which expression results in an irrational number? So there's a couple different ways to define this and look at this. An irrational number is a number that, if it's a decimal, it's going to be non-terminating and non-repeating. I think that's the easiest way to look at this. Non-terminating means it's not going to stop, and also non-repeating. So a number like 0.333 with a bar over it, that doesn't terminate, but it does repeat. It's just a 3 repeating over again. So 0.3 with a bar over it would be rational. When we talk about irrational numbers, we're talking about decimal numbers that never end and don't have any type of pattern. There's no repetition in it, okay? When I simplify number 1, I have radical 3 times radical 3. That's the same as radical 9. And radical 9 is just the number 3. So that's rational. That's just the whole number. So number 1 is out. Number 2, when I add, another way that you can justify this, if I'm adding a rational number plus a rational number, I'm always going to get a rational number. So if I add these, I will get a decimal, but it's going to be negative 0.416 with a bar over it. So again, there's repetition there. So even though it doesn't end, there's repetition. So it is rational. One thing to note is that if you put this in your calculator, you may get 0.41 and a bunch of 6s and then a 7 at the end. Don't let that 7 fool you into thinking that it's actually ending or changing the pattern. That's just the calculator running out of room and rounding it. So don't let that fool you. That's still just 0.416 with a bar over it, negative in this case. All right, choice number 3, the square root of 81 is 9, and 9 times 5 is 45. So we have another whole number here, so that is also a rational number. And lastly, we have 1/3 plus square root of 3. The hint here that you really can know right away that this is going to be irrational is because 3 is not a perfect square. Whenever you take the square root of a non-perfect square, you get an irrational number. And then adding 1/3 to it is still going to keep it irrational. But you can just throw this in your graphing calculator, 1/3 plus the square root of 3, and you're going to get a decimal. I think I wrote it down. It's going to be something like 2.06538. There's not going to be a pattern, and it's not going to end. And so that's going to go with this definition we said here. It's non-terminating, it's non-repeating. So number 4 is going to be our irrational number here. Number 8, which equation has the same solution as x squared plus 6x minus 18? When you look at the answer choices here, Hopefully it looks familiar to you and it looks like a completing the square problem. The format that it's written in is x plus something squared equaling a constant. That's your hint that this is about completing the square. So let's review how to complete the square. The first thing we need to do is get that constant to the other side. So I'm going to add 18 to both sides of this equation. I'm going to bring my work down here. So that's going to give me x squared plus 6x equals 18. I'm leaving this space because when we complete the square, we have to add something to both sides of the equation. So what we're going to do is take half of the b term. Remember the b, even if you don't remember it, it's in your reference sheet, right? The b is the coefficient of x. So the b in our case is 6. We're going to take half of b and then we're going to square it. And that's the number that we're going to add to both sides of this equation. So half of b is 6. So I'm doing 6 divided by 2 and I'm squaring it. 6 divided by 2 is 3, so I get 3 squared, which is 9. Once you do b over 2 and you square it, that number that you get, you're adding it to both sides of the equation, okay? So on the right side, I'm going to get 27. And before I even move on, I'm going to go ahead and cross out answer choice 3 and answer choice 1 because they have 24 on the right side, so I already know those are incorrect, all right? Now on the left side, we have to factor this. So just like number 1, we would factor this by doing product and sum. So we're looking for two numbers whose product is 9 and sum is 6. We don't have to think very hard because the whole purpose of completing the square is that you're always going to end up with a perfect square trinomial. So the number that's going to go inside when we set up those binomials is always going to be half of b. So it's going to be x plus 3 times x plus 3, right? 3 plus 3 is 6 and 3 times 3 is 9. Now, I'm multiplying x plus 3 by itself. So when you multiply anything by itself, that is the same thing as squaring it. So I'm going to rewrite that as x plus 3 squared equals 27. And that looks pretty much like answer choice number 2. All right. Number 9 is talking about a box plot. So we can do this by hand or we can do this in the calculator. I'm going to show you how to do this in the calculator. So if you go to your TI-84 and you hit the stat button, we're going to hit edit, and then we're going to take all the values that were given to us for the box plot. We're just going to enter them in list 1. So we have 76. Oops. You're just going to hit enter. 70, 72, another 70, 69, 71. You don't have to put them in order just in case you're thinking that when you do this by hand, you do need these to be in order, but the calculator is going to do all that work for us. All right, so we entered all the values into our list 1. Now you're going to hit stat again. Oops. Sorry. Now we're going to hit second and then y equals so we can now access the stat plot. So you see how they're all off? We're actually going to hit number 1. So I'm going to hit enter on stat plot 1. And I'm going to toggle that to on. So right now it's on off. I'm going to go to on and hit enter. And then we're going to scroll down and we're going to choose the type of plot we want to see. So if I scroll to the right, this box plot that's blinking right now, you can use it. What that one's going to do is take outliers into consideration so that if there's an outlier in the data, it's going to plot it separately from the box plot. This other box plot to the right that's blinking now is not going to plot the outliers separately. So I'm going to go ahead and choose that one. We don't need the other one. So I'm going to hit enter on that. And now I'm going to go zoom 9 just so it fits it nicely so that we can graph it. So that's what our box plot looks like. Obviously, we need the exact values so we can see which graph matches it. So if you now hit trace, you'll start to see that little pointer kind of blinking on that's the median. So the line that's in the box is the median. And if you look down in the bottom left of the screen, you'll see that it says median. I don't know if you guys can see that well. Oops. Sorry. Let's take you back. Okay, trace. Just want to zoom in on this to make sure you can see. So see on the bottom left, it shows me that my median is 71.5. So, and I'm going to scroll left to show you the other values. So Q1 is 70. So if I look at the box plots that are in my answer choices, I'm looking for the one that has the box beginning at 70. That's all of them, so that doesn't help me eliminate anything. The minimum value, if I scroll all the way to the left, is 69. If I look at my answer choices, I can eliminate 1 and 2. I know you can't see them right now. I'll go back to them in a second. Because they have their minimum at 65. So now I already know I'm down to choices 3 and 4. And again, if I go back to that median, the median is 71.5. So let's go back to our box plots. We eliminated 1 and 2 because they had the wrong minimum value. Out of 3 and 4, I need the median to be a 71.5. So if I look at this line right here and I go down, I see that it's between 71 and 72. So that looks like it is 71.5. Let's just double check number 4. If I look down from this median, they made it very close, which is very annoying, but that median is between 72 and 73. So it is just a little bit off, but off nonetheless. So number 3 is our answer choice here. Number 10, a bookstore owner recorded the number of books sold and the profit made selling the books. What is the average rate of change? So rate of change is the same thing as your slope. And again, remember we said that slope formula, I don't know why, but it's on your reference sheet. So use it, all right? That slope formula is there. They want to know the average rate of change in dollars per book between 100 and 350 books sold. So if you were finding the rate of change of a linear function, you could pick whichever 2 order pairs you want because there's a constant rate of change. If they're asking us to find the average rate of change, that usually means it's because there isn't a constant one, but they want to know the rate of change between those 2 specific values. Oddly enough, in this problem, the rate of change is the same throughout. So I don't know why they did that, but that's okay. So we're looking for the change from 100 to 350. So at 100 books sold, they made a profit of $50, and at 350 books sold, they made a profit of $425. In order to use my slope formula, so I'll bring it over here for you, m equals y2 minus y1 over x2 minus x1. You need 2 order pairs. We have them. Your books sold are your x. They're your independent variable. Depending on how many books you sell, you will make y profit. So I'm going to call 100 my x1, and if that's my x1, then my 50 has to be my y1. So 350 is my x2 and 425 is my y2. And now I'm just going to substitute those values into this formula. So I'm doing 425 minus 50 over 350 minus 100. So that's going to give me 375. Sorry, my work is a little sloppy over here. Over 250. And if I divide 370 over 250, I'm going to get $1.50 per book as my average rate of change here. Number 11, if f of x equals x squared, which function represents a shift of the graph of f of x 4 units to the right and 3 units down? Okay, so important and confusing fact to remember here is that when you're doing a horizontal shift, meaning we're moving left or right, that change, if you can remember this, is going to be inside the parentheses. It's going to be with the x. If we are talking about a vertical shift, meaning that we're moving up and down, that change is going to be shown outside of the parentheses. It's going to be the number that's being added or subtracted outside of the parentheses. Second important thing to know, when you're moving left and right, if you are moving to the right, we are subtracting. And if we're moving to the left, we are adding, which seems a little bit backwards, but hopefully you can remember that. So if we're going to shift 4 units to the right, and I just told you that right means subtract, and that the horizontal shift is inside of the parentheses, then that means that we are looking for a 4 to be subtracted from the x inside of the parentheses. So I'm looking at my answer choices and I see that 1 and 2 are gone because that has a plus 4 inside, and we said it's going to be a minus 4. Now we look at the vertical shift. It's going 3 units down. So I told you guys that the vertical shifts are going to be outside, I keep doing that, are going to be outside of the parentheses, and that, well, I didn't tell you this yet, but for vertical shifts, it's a little more intuitive. If we're moving up, then we're adding a number outside of the parentheses. If we're moving down, then we are subtracting a number outside of the parentheses. So if we're going 3 units down, that means we're subtracting. So that's going to be answer choice 3 here. Number 12. The amount of money a plumber charges is represented by the function P of H equals 45 plus 90H. The best interpretation of the y-intercept of this function is that the plumber charges what? Well, let's first figure out what the y-intercept is. So in a linear equation written as y equals mx plus b, the y-intercept is the b value. Now, if you notice the equation they gave us, looks like it's in y equals mx plus b, but they have the x, or the h in this case, the independent variable, being written second. So they're trying to trick us here. Just because it comes second doesn't mean that it's the y-intercept. The number that is being multiplied by the independent variable is your slope. So the 90 in this case is the slope. The y-intercept is always going to be the number that is a constant, that is by itself. The y-intercept is some type of fee, some type of a one-time charge. It's never going to be multiplied by a number. So the number that is alone in this equation is the 45. So first things first, we have to know that our y-intercept is 45, which means that answer choices 3 and 4 are out. 90 is the slope, 45 is the y-intercept. So now what does it mean? Well, it's either the charge to come to the house or the charge per hour that he works. This per hour right here is why I'm going to cross out number 2. Y-intercept will never represent something per hour or for each, yada yada, for every whatever. The y-intercept is a constant. It doesn't change based on anything else. It's not being multiplied by any variable. So it has to just stay the same. It's always some type of fee. So when they say $45 to come to the house, that probably means the plumber's travel fee. So that is what this represents in this case. Number 13 gives us an inequality. So inequalities are very similar to equations and how we solve them, except for one important difference, which is going to show up in this inequality later. So we're going to start by distributing that 3 that's on the right side of the inequality. I'll bring down the left side. So we have 2m minus 4 is less than or equal to 6m plus 12. Now I want to get my variable on one side. I can either subtract 6m or I can subtract 2m. Normally I would subtract 2m so I don't have to deal with negatives, but I know a lot of you like to see the variable on the left side of the inequality. So I'm going to subtract the 6m. And if I do it on the left, I have to do it on the right. And I have to do it to its like term. So I can't subtract that 6m from the negative 4. I have to subtract it from the 2m. 2m minus 6m is negative 4m. I'm going to bring down that negative 4. I'm going to bring down my less than or equal to sign. 6m minus 6m cancel out. And I'm going to bring down that positive 12. Now again, similar to solving an equation, you're trying to get the variable by itself. So we're just doing the inverse operations of everything else that's around it. It's easier to get rid of addition or subtraction first, so I'm going to add 4 to both sides now. And I'm going to bring my work up here. Sorry, there's not much room here. Negative 4m is less than or equal to 16. So I added the 12 plus 4 to get me 16. And now that m is almost isolated, it's being multiplied by negative 4. So the inverse of multiplying by negative 4 is dividing by negative 4. So I'm going to divide both sides by negative 4, because if I do that on the left, negative 4 divided by negative 4 is just 1, so that gives me m. And then on the right, 16 divided by negative 4 is negative 4. However, this is where the difference comes in between solving equations and inequalities. If you divide or multiply by a negative number in the inequality, you have to change this inequality sign. So what was once a less than or equal to sign is now going to be a greater than or equal to sign. And that happens again when you multiply or divide by a negative number. So here is my answer. M is greater than or equal to negative 4, which is answer choice number 4. Right. Number 14, a survey of students at West High School was taken to determine a theme for the prom. The results of the survey are summarized in the table below. Approximately what percentage of the students who chose the Broadway theme? I'm going to stop right there. As soon as you see that of, whatever's after the of, so who am I talking about? Who's my total? I'm looking at the students who chose the Broadway theme. That is whatever comes after the of, that is going to be your denominator. That's what we're talking about, something out of. So out of the students that chose Broadway, they want to know how many were girls. So this part is going to go in my numerator. Now, how many students chose the Broadway theme? Well, let's look at the Broadway column. There are girls and boys that chose Broadway. And so all the students who chose Broadway, I have to add them together. And so when I add these two together, I get 147 total students that chose Broadway. So that's going in the denominator. They want to know what percent of that was girls. So looking at the girls who chose Broadway, that intersects right here. So it is 68. So I'm just going to divide 68 by 147. That's going to give me a decimal that is something like 0.4625, and it's going to go on. So something like that. And now to make a decimal into a percent, I multiply by 100. So that's going to give me 46.25 something something. And I'm just looking to round that. And so answer choice number 3 looks close to what I have, about 46%. All right, number 13. So 13, I want to say, is something that's kind of new. You see, we haven't really seen anything new yet. If you've been studying from Barron's and you've been looking at 2023 tests, 2022 tests, they're still pretty similar. This I don't think showed up before. So when we're adding radicals, it's very similar to adding like terms. You can't add them together unless they have the same radicand. So the radicand is the number that's under that square root sign. So unless these two numbers were the same, the 54 and the 6, I can't combine these. So what I'm going to show you how to do is simplify the 54 so that we get it to be a square root of 6 and then we can combine it. So to simplify the square root of 54, I want to rewrite it so that it's some square root times some other square root. And I want one of the square roots to be a perfect square. So I'm talking about numbers like 4, right? 4 is a perfect square because the square root is 2. 9, 16, 25. So you want one of your numbers, one of your factors to be a perfect square. The kind of cheat code here is if we need the other radical to be a 6, then just divide the 54 by 6 and it'll tell us what the other one should be. And so of course that gives us 9, which is a perfect square. So I can rewrite the square root of 54 as a square root of 9 times the square root of 6. Why does this help me? Because the square root of 9 is just the number 3. So that means that square root of 54 is the same thing as 3 times the square root of 6. So now I'm going to rewrite this. So this was 2 times the square root of 54, but now I'm rewriting it as 3 radical 6 instead, plus 2 radical 6. All right, these numbers I can multiply. So 2 times 3 gives me 6. So now I have 6 radical 6 plus 2 radical 6. Now that the numbers inside of my radical sign, my 2 radicands, now that they're the same, I can combine these the same way I combine like terms, which means that you're going to add the coefficient. So that gives me an 8, and we're going to keep that radical the same to give me 8 radical 6, which is answer choice number 4. Now, let me take you back to your calculator because you can definitely just do this in your calculator as well, or at least to check it. So if I take, let's see, 2 radicals, so I'm doing second square root to give me the radical sign, 54. Now, you got to hit the right button so it gets you out of the square root sign. And we're adding that to 2 radical 6. That's going to give me this long decimal. All right, so now I'm going to make sure that 8 radical 6 has that same value. And sure enough, it does. So that's a really easy way to use your calculator and check. Or if you forget what I just showed you about how to simplify the radical, you could just go through all your answer choices and check and see which one gives you the same value. So that is a longer way to do it. All right. Number 16, the functions f of x and g of x are graphed on the same set of axes. What are the solutions to the equation? When we're looking for the solutions to f of x equals g of x, we're looking for where do they intersect. So when we ask for solutions, we're asking for where are they intersecting. There's an algebraic way to do this and there's a graphing way to do this. I think I'll show you on your calculator first because that's probably the way that you guys are going to like better. So to do this with graphing, let's go to our calculator and we're going to graph, where did they go? We're going to graph both of these equations. So let's graph x squared minus 5x minus 14. And then scroll down and we're going to graph the other one. So we're going to graph x plus 2. All right, now oops, sorry, I'm on stat plot. So now I got to go back. This is a good lesson for us. So if we just did a box plot problem, I have to go to second stat plot, go to plot 1, which was turned on, and we're going to turn it off. Okay. Let's make sure I did that. Yep, that's off. Okay, so now let's move up to y2, and we're graphing x plus 2, and it is not graphing y. Let's see. Oh, because my window is set kind of crazy. All right, so let's reset our window to have a x min of negative 10, 10, negative 10, 10. All right, and that fixes it. And actually, I should probably make my window go a little bit higher because I see there's two intersection points, but I can't really see the one that's to the right. If you look at the top right corner, I can't really see that one. So I'm going to go to my window, and I'm actually going to make that y max. Let's go to 13 and see if that does it. Yeah, that makes it a little bit better. Now I can see both. So we graph both equations. The solutions are the points where they intersect. And so to find this, I'm now going to go, let's go to our second trace. All right, so we are going to look for our, second trace. We're going to intersect. And now we want to get our little cursor to be near the first point of intersection. So just kind of scroll with your cursor until you see that little blinking guy somewhere on the curve. So you see him on the blue curve now. You see how it's asking you at the bottom left first curve. So I'm going to hit enter. And now it's asking me, am I on the second curve? So it's kind of confirming, am I on the other equation now? It is, so I'm going to hit enter. It's asking me, do you want me to guess? Yes, hit enter. And it's giving us the first point of intersection, which is happening at -2, 0. Let me scroll in so you guys can see that. All right, so you see it's giving us the intersection at -2, 0. When we look for the solutions, we're only interested in the x values. So I know that one of my solutions here is going to be -2. Now we need the other one. So you see there's another intersection point on the top left. So if I do that again, I go to second trace and I hit 5 for intersect. Now I'm going to scroll my little guy all the way over to the right side of the curve until it's closer to that other point of intersection. Let's wait for him to appear. There he comes. All right. Now I'm going to hit enter here. It's asking me, am I on the second curve? Hit enter here, hit guess. And now it's giving you that second point of intersection. If you look at the bottom left, it's telling us that it's intersecting at 8, 10. Again, I'm only looking for the x values. So if I go back to my answer choices, I see that those two values are right here, -2 and 8. So number 3 is going to be the answer. Now, you could do this by factoring. So we could set, if we're looking to see when these two equations intersect, we could set them equal to each other and then factor. You might want to fast forward through this, but if you're willing to see it algebraically, I'll do it kind of fast. But we're basically asking ourselves, when will this equation equal this equation? So I'm going to move all of my terms to the left so that this equation can be set equal to 0. So I'm going to subtract x from both sides, and I'm going to subtract 2 from both sides. I'm just going to do it at once. So I'm subtracting 2 from the constant and from 2, and I'm subtracting x from the x and the -5x. So that's going to give me x squared minus 6x minus 16 equals 0. Now that I have this equation that equals 0, I can try to factor it by that same method we've done now 3 times, product and sum. So I'm looking for two numbers that give me a product of -16 and give me a sum of -6. And those two numbers are going to be -8 and +6. So I'm going to write that as x minus 8, and I'm sorry, and x plus 2. Right? -8 times +2 is -16. -8 plus 2 is -6. Once I factored it, now I can set each of these expressions equal to 0 and solve. So if x minus 8 is equal to 0, if I solve that one-step equation, I'm going to get x equals 8. That's where that answer comes from. And if I set x plus 2 equal to 0, and I subtract 2 on both sides, I'm going to get x equals -2. That's where that second answer comes from. So always an algebraic way and a graphing way to do it. It's good to know both. You have 3 hours to take this region. So if you get through it and you did it one way, you can always go back and try the other way. All right, let me erase some of this to just kind of give us some space here. 17 says if x equals 4a squared minus a plus 3, y equals a minus 5, which polynomial is equivalent to the product? So a little more vocabulary here, probably an easier vocabulary word though, but we need to know that product means it's asking for us to multiply. So we're just multiplying these two expressions together. They want to know the product of x and y, but they told us that x is equal to this long thing, y is equal to this expression. We need to multiply those two together. I personally like to always set up the shorter binomial or the shorter expression first. So we're doing a minus 5 times 4a squared minus a plus 3. Again, product means to multiply, so we're just multiplying these polynomials together. We're going to distribute that a out to every term in the other parentheses, and then we're going to distribute that -5 out. So let's start with the a. A times 4a squared gives me 4a to the third power. a times negative a. Again, remember to look at the sign before the term. A times negative a is negative a squared. A times 3 is positive 3a. I'm done distributing the a. Now I have to distribute this negative 5, again, to all three terms in the other parentheses. And I'm just going to keep writing the terms right next to the other ones I've already done. So negative 5 times 4a squared is negative 20a squared. Negative 5 times negative a is positive 5a. And negative 5 times positive 3 is negative 15. You're done distributing. Now you got to look for like terms. And again, remember to always look at the sign before it to determine what we're doing. Are we adding or subtracting? So for a cubed, there is no like term because there's no other term that has an a cubed. So that's just going to stay there. I'm looking for a like term with negative a squared, and I see a negative 20a squared. So I'm going to do negative a squared minus 20a squared. That's going to give me negative 21a squared. Now I'm looking for a like term with positive 3a. So I see positive 3a plus 5a. That's going to give me positive 8a. And then lastly, I can always combine numbers. Did I miss a number somewhere? No, there's only one constant number, which is that negative 15. And so that negative 15 is just going to come down into our answer. There's nothing else left to combine here. So that means that I've simplified it as much as I can. And that looks like answer choice number 4. Okay. Number 18. What is an equation of the line that passes through 3, 7 and has a slope of 2? Your reference sheet. This is exactly what I'm talking about here. So your reference sheet has the equation of a line in both forms. You'll notice when I take you back to the question, all of those answer choices are in what looks like point slope form. So the equation is right here for you. This problem will be very easy if you use your reference sheets. Let's go back to number 18. You see all the answer choices look like they're point slope form. So we're going to use that form. So again, from the reference sheet, it's y minus y1 equals m times x minus x1. Our m, just like it is in y equals mx plus b, is our slope. Our y1 combined with our x1, that together is going to be a point, right? x1 comma y1. So if I go back up to my problem, I can annotate the point they gave me. The 3 is my x1 and the 7 is my y1. Now, if I just carefully substitute everything I have in front of me, I'm going to get the right answer. So looking at my equation over here again, straight from my reference sheet, it's going to be y minus y1. Look above it. Y1 is 7. So y minus 7 equals m, our slope, we were told in the problem is 2, times x minus our x1 from the problem is 3. And in a couple of seconds, we are done. And number 1 is the correct answer choice here. Number 19, a geometric sequence with a common ratio of negative 3 is. This is more vocabulary. A common ratio is just the number that you're multiplying each term by in a sequence to get to the next term. So you're just looking for the sequence. First of all, that's geometric, right? So you don't want to be adding each time. Geometric means that we're multiplying. And each time you're multiplying by negative 3. So if I look at choice 1, you see they're trying to trick you there. We're adding 3 both times. So they're involving the number 3 somehow. They're putting negatives in there, but that's not it, right? That's not even geometric. That's an arithmetic sequence because we're adding. If I look at number 2, I'm subtracting 3. So maybe that's where they're hoping to get you with that negative 3. But again, it's non-multiplication, so it's out. Number 3, there is multiplication happening, but it's not by negative 3, because if you do negative 2 times negative 3, you would get positive 6, but they have negative 6 as their next term, so that's incorrect. Answer choice number 4, if I do 4 times 3, I get negative 12. If I do negative 12 times negative 3, I get positive 36. Positive 36 times negative 3, negative 108. 4 is my answer choice. Common ratio, the number you multiply a term by to get to the next term. Number 20, when the equation 6 minus ax equals ax minus 2 is solved for x. When it says solve for x, get x alone. That's what it's telling you to do. Solve for x, solve for y, solve for whoever. Get that variable by itself. That's what it wants us to do. In terms of a, and a is not equal to 0, what is the result? So let's get moving with some of these terms. I'm going to start by adding ax to both sides, okay, because I need this x term to be together. So I could have subtracted ax from both sides also. Again, I like to try to avoid negatives when possible. I'm going to bring down that 6. Opposites are always going to cancel out when I add them because they equal 0. On the right side of my equal sign, ax plus ax equals 2ax. And then that minus 2 is going to come down. Remember, my goal is to get the x alone. It's not always going to be x, so just be careful with whatever variable they're telling you to solve for. I want x alone, so I'm going to add 2 to both sides. When I do that, I'm going to get 8 equals 2ax. Now that x is being multiplied by 2a, so I'm going to do the opposite, and I can do it all at once. I don't have to divide twice. I'm going to divide by 2a on both sides. Because if I divide 2a divided by 2a, I'll get 1, and that'll leave me with just x on its own. And on the left side, 8 divided by 2 is 4, and that a is still there in the denominator. So x is equal to 4 over a, which is answer choice number 2. I'm going to delete this to give us some space for the next one. Which function has the zeros -1, 3, and -4? So this is, again, to me, very important vocabulary. The zeros are also known as the roots. They are also the y-intercepts. And I think knowing that they're the y-intercepts is what's going to make this problem the easiest for you. I would graph this. So I did take a screenshot of the graph of these to make it a little quicker for us. So if you graphed each of these functions, once you get to the correct one, you're looking for which one of them has, I'm sorry, I just said x-intercepts and I meant y-intercepts. Change that. Which one has x-intercepts at these 3 numbers? So I'm going to scroll down to, here's my screenshot of the correct answer. And you'll notice that if I look at this graph, I have an x-intercept right here, and right here. So when I graph these, this is -3. The one to the left of the origin is -1, and over here, this one is at 3. So you're just looking for which of these graphs is going to give you the correct x-intercepts. And that happened when I graphed answer choice number 3. So that's one way that you can do this, is just go in your graphing calculator, graph these, and see which graph is going to give you x-intercepts at those points that they're asking you for, okay? The other way to look at this is that when we're looking for the x-intercepts, we're basically saying when's the y value 0, or the f of x, g of x, whatever it is, 0. So if I set, and I'll show you algebraically that 3 is correct, if I set h of x equal to 0, I'm looking to see what the x values are that would make this equation true. Well, if I'm multiplying 3 things together and I'm getting 0 as the product, then at least one of those things had to be 0. That's the only way you get 0 by multiplying. So if I multiplied x plus 1 times x minus 3 times x plus 4, and I got 0 as the answer, the way that happens is one of those, or all of those, or 2 of those are 0. So I'm going to set each of these equal to 0 and then solve. So if I just do a little one-step equation here, I get x equals -1. That's my first 0. If I add 3 to both sides here to get x alone, I'm going to get x equals 3. There's my second 0. And if I subtract 4 from this last equation, I will get x equals -4, and that is my last 0 that they asked for. So answer choice number 3 is correct. Again, doing it on a graph is also probably an easy way to do it. Number 22, we need to know our exponent rules for this one. So it is asking us, the expression 5 to the a plus 2 plus b power is equal to which one of these? All right. Well, number 1 has the same base being multiplied. And so the laws of exponents tell me that if I'm multiplying with the same base, which is 5, that I can keep that base and add the exponents. So when we're multiplying powers, we keep the base and we add the exponents. So that would give me 5 to the a plus 2 plus b. While it looks kind of like what I have in here, it's not the same thing. And so answer choice number 1 is out. A plus 2 plus b is not the same thing as a plus 2b. Not the same, right? Answer choice number 2, well, I'm going to first change this 25 so that it also has a base of 5. So 25 is the same thing as 5 squared, right? 5 times 5 is 25. So that's the same. So I'm going to rewrite this as 5 squared to the b power. And I'm going to bring down my 5 to the a power. Now, another exponent rule you need to know is that when you're raising a power to another power, so that's what we have right here, when you're raising a power to another power, you multiply those exponents. So that part is going to simplify to 5 to the 2b. I'm multiplying 2 times b, so I get 2b. Bring down that times 5 to the a again. And remember what we said in answer choice 1, when we're multiplying powers, we have the same base, which we do. We have a base of 5 now. You add the exponents. So now I have a plus 2b. And that is exactly what I had in this question. So answer choice number 2 is correct here. Number 23. In an arithmetic sequence, the first term is 4. So let's just kind of draw this out. First term is 4. And the third term is 2. So that's the first term. I don't know what the second one is. And then the third term is negative 2. What is the common difference? Okay, 2 ways we can look at this. Remember, you have, again, on the reference sheet, the formula is there for an arithmetic sequence. So I'll show you how you can use that. And then I'll show you how you can just kind of use common sense, to be honest with you. So the formula that's going to be on your reference sheet is a sub n equals a sub 1 plus d times n minus 1. D is your common difference. So this is your, let me write this out for you guys. D is your common difference. A sub 1 is your first term. And a sub n is your nth term. So your first, second, third, whatever you're going to replace the n with, okay? In this case, they gave us the first and they gave us the third. So if I'm going to say that n is 3, because they gave us the third term, then a sub n needs to be the third term. The third term is negative 2. So now I have negative 2 equals a sub 1 is our first term, that's 4, plus the common difference I don't know, so I'm going to leave it as a variable d. And that's going to get multiplied by n minus 1. Our n is 3, right? Because we're talking about the third term. So 3 minus 1. So this simplifies to negative 2 equals 4 plus d times 2, which I know looks like a weird way to write it. I'm solving for d. So if I subtract 4 from both sides, I'm going to bring my work over here. That's going to give me negative 6 equals, I'm going to rewrite that as 2d because d times 2 looks weird. I'm trying to get d by itself, so divide by 2, and we get that the common difference is negative 3. If it was negative 3, then the second term would be 1 because we're subtracting 1, right? If we're adding, the common difference is the number that you're adding to each term to get the next one. So 4 plus negative 3 gives me positive 1. 1 plus negative 3 does give me that negative 2 that I have next, okay? So the formula, which is straight from the reference sheet, is one way you could have done this. The other way to do this is to think about it as, all right, you have 4 something and then negative 2. The difference between the first term and the third term, they tell you is, did they tell us it's negative? Sorry. No, we could find it, right? So to get from 4 to negative 2, that means I went down 6. I subtracted 6. But I'm not just going from 4 to the next term. I had to do 2 cycles of subtraction, essentially. So what you can do is take the whole amount that you had to add, which is negative 6, and just divide it by the number of times that we're going to have to subtract. And we did 2 loops. So negative 6 divided by 2 is negative 3, which means that each time we're subtracting negative 3. I hope that part makes sense. All right. Those are all the multiple choice questions. That was a lot of talking for one video. So I'm going to save the part 2, 3, 4, all the open-ended questions for another video if you guys want to go through those. Hopefully this helped you in learning what vocabulary and types of problems you need to focus on. Let me know if there's any topic that you feel like you need more help with, and